Press your palm flat against a dark roof at 2 in the afternoon in July. You pull it back. That surface is running 150 degrees Fahrenheit. That heat is moving through your roof decking, into your attic, through your ceiling insulation, and into every room below it. Your air conditioner is running a marathon against it all day long and losing, degree by degree, while the electric meter spins. A coat of white paint on a 1,000 square foot roof produces 10 kilowatts of continuous cooling power. That is more than the central air conditioning unit running inside most American homes right now. No compressor, no refrigerant, no wiring, no electricity bill, just paint. A homeowner named David Mundy bought 2 bags of hydrated lime from the concrete aisle of his hardware store for $14 total, rolled it onto his roof in one afternoon, and dropped his attic temperature by 40 degrees Fahrenheit. His air conditioning barely cycled all summer. You cannot do this in most American neighborhoods. The reason has nothing to do with safety. This is the story of what this paint is, how it works, who made sure you never heard about it, and what you can legally do about it today. The idea behind this is so old it predates written language. Every Mediterranean civilization figured it out independently. The Greeks, the Romans, the Moors, the Andalusians. Across the Cycladic Islands, residents have been lime-washing their buildings white since the Byzantine era. Santorini, Mykonos, Paros. Those white walls are not decoration. They are a cooling system. The thick stone stays cool. Interior temperatures hold around 72 degrees Fahrenheit through summers that push well past 95 degrees outside. No electricity, no moving parts. Crushed limestone mixed with water, painted on every spring. Thousands of miles apart. Thousands of years of practice, all converging on the same answer. In 1902, Willis Carrier invented mechanical air conditioning. And from that point forward, the answer to heat was no longer a material. It was a machine. A machine that could be manufactured, installed, serviced, and billed monthly. Limewash could not do any of those things. You buy it once for a few dollars and paint it on. That is where the trouble started. In the early 1990s, a physicist named Hashem Akbari at Lawrence Berkeley National Laboratory in California began doing something nobody in the building industry had done at scale. He started measuring what actually happened when you took a dark roof and made it white. Not modeling it. Not estimating from energy bills. Thermocouples on the roof surface, temperature probes in the attic, submeters on the air conditioning compressor, data loggers recording every 15 minutes, month after month, in real occupied homes and real commercial buildings across Sacramento, Florida, and Central California. The numbers were not subtle. A home in Sacramento coated with a high reflectance white surface saw an 80% reduction in daily air conditioning electricity use. Not a typo. 80%. A school building in Florida recorded a 25 to 35% drop in cooling energy. 3 commercial buildings across Central California showed 17 to 39% reductions. The Florida Solar Energy Center replicated the residential findings across 9 occupied homes and found significant cooling reductions at every single site. All published, all peer-reviewed, all sitting in the Lawrence Berkeley Archives and the Department of Energy database where anyone can download them today. In 2011, white test plots on the roof of the Museum of Modern Art in Queens were measured at 40 degrees Fahrenheit cooler than identical plots painted black. Same roof, same sun, same afternoon. The only variable was color. Akbari spent 3 decades building the most comprehensive evidence base in building energy research history. His work pushed reflective roof requirements into California Title 24 and eventually into ASHRAE 90.1, the national benchmark for commercial building energy performance. Those standards took decades to pass. They still only apply in limited contexts. they still do not require a white surface on every residential roof in a cooling, dominant climate. The data was never in question. The adoption was. In 2021, a mechanical engineering lab at Purdue University created a formulation so white that Guinness certified it as a world record. It reflects 98.1% of all incoming sunlight. But that is not even the main achievement. A standard white roof reflects heat. A dark roof absorbs 90 to 95% of incoming solar energy and reaches surface temperatures of 150 to 170 degrees Fahrenheit on a summer afternoon. A good commercial white coating reflects 80 to 90% of that energy and drops the surface temperature significantly. That alone cuts cooling costs by 20 to 40%. That technology exists right now at any hardware store. Purdue's paint does something no ordinary white paint has ever done. It does not just bounce heat away, it actively radiates heat off the surface through the atmosphere and into deep space. The paint uses barium sulfate nanoparticles at 60% concentration in a calibrated range of particle sizes. Each size scatters a different wavelength of sunlight, covering more of the solar spectrum. But the real breakthrough happens in the infrared. The paint emits thermal energy at 8 to 13 micrometers, the precise frequency band where the atmosphere is transparent. Engineers call this the atmospheric window. Energy radiated at those frequencies passes straight through the air, through the clouds, and exits into the cold of outer space at minus 270 degrees Celsius. The surface it coats does not just stay cooler than a dark roof, it drops below the temperature of the surrounding air in direct sunlight. Purdue's field test recorded the painted surface sitting more than 4.5 degrees Celsius below ambient air temperature during the day. At night, that gap widened to more than 10 degrees. The surface was actually cold. 6 years of research, over 100 candidate materials evaluated, published in ACS, Applied Materials and Interfaces. Funded in part by the Air Force Office of Scientific Research. CNN covered it. The Smithsonian wrote it up. Every major science outlet in the world ran the story. And then, nothing changed. The global air conditioning industry is not a small business. According to the International Energy Agency, cooling already accounts for roughly 10% of all global electricity consumption. About 20% of all electricity used in buildings worldwide goes to air conditioning and fans. By 2050, the global stock of air conditioners is projected to grow from roughly 2 billion to 5.6 billion units. That is 10 new air conditioners sold every second for the next 25 years. The energy demand from cooling alone is expected to triple. That is not a market that reorganizes itself around a coat of paint. Then there is the layer most homeowners never think about. Homeowner association rules. Across dozens of states, HOA covenants explicitly restrict roof and exterior colors to earth tones: browns, grays, dark greens, muted reds. Those are the colors that look traditional and uniform. They also happen to be the colors that absorb the most solar energy and guarantee that your air conditioning runs all summer. A white or highly reflective roof is often a direct violation. This is written into HOA rulebooks. You can look it up for your own community right now. Nobody sat in a room and decided to suppress radiative cooling paint. That is not how it works. The air conditioning industry sells equipment that requires electricity. The paint industry sells products designed to be replaced. The building code system was designed around both. The HOA system enforces colors that maximize heat absorption, and a surface that cools itself for free does not fit the revenue model of anyone in that chain. Nobody needed to coordinate. Nobody needed to conspire. Everyone involved simply followed their financial interest, and the result was the same as if they had planned it in a room together. Your neighborhood aesthetic code may be quietly requiring you to maximize heat absorption on the largest sun-facing surface of your home, and then pay to remove that heat with a machine every month for the rest of your life. That is worth stopping on. The Purdue formulation has not reached store shelves. Patents have been filed through the Purdue Research Foundation and a production partner has been secured. But as of now, it is not available to consumers. What is available at any major hardware store today is high-reflectance, white elastomeric roof coating. A 5-gallon bucket costs roughly $60 to $120, depending on brand and rated lifespan. It covers approximately 250 square feet per gallon with a proper 2-coat application. For an average flat roof, you are looking at $250 to $500 in materials and a weekend with a roller. These coatings reflect 80 to 90% of incoming solar radiation, not 98.1%. But 30 years of Lawrence Berkeley field data show they reduce cooling energy by 20 to 40% in most climates. On a home spending $2,000 a year on cooling, that is $400 to $800 back in your pocket every summer. The coating pays for itself in the first season. Compare that to a new central air conditioning system. $5,000 to $15,000 installed. $500 to $2,000 in annual electricity costs. A 15-year lifespan before you repeat the entire process. And every kilowatt hour it consumes generates emissions that make the problem it is solving incrementally worse. David Mundy did not use the commercial coating. He used $14 worth of hydrated lime from the concrete aisle and dropped his attic from 140 degrees Fahrenheit to 100 degrees in a single afternoon. He published the temperature data, the process, and the cost breakdown. It is still freely available online. Before you start, check your HOA rules. If white is restricted in your community, you are being required by private covenant to maximize heat absorption on the largest sun-facing surface of your home, and then pay to remove that heat every month for the rest of your life. That is not an accident. That is the system working exactly as designed. The same coat that kept a Greek grandmother comfortable in 1850 works exactly the same way today. 30 years of peer-reviewed field data, a world record formulation sitting in a lab in Indiana, a $14 solution. Any homeowner can roll on in an afternoon. The building industry did not need to ban it. It just needed the code to ignore it, the HOA to prohibit it, and the AC unit to keep running. Purdue's team calculated that coating 0.5% of the Earth's surface with their formulation could offset the warming effect of all carbon dioxide emitted to date. The paint exists. The data exists. The only thing missing is the roof.